We have a team teaching approach here for the first thing this afternoon. Don Glosser, Director of Engineering for the American Concrete Pavement Association. I hope I get that right.
You got that right.
That's hard for me to say that. Don's background is he's an Ohio State University graduate engineer and a professional engineer in Ohio, and he has engineering experience in North Carolina and with the Marion County Engineer's Office, and been down here with the ACPA for
4 years.
4 years as the Director of Engineering. And then Jim Barnhart will be, I don't know how they're going to work this, but Jim is a staff engineer. Jim's retired from ODOT. I have a hunch he's a Ohio U or Ohio State? Indiana Tech. Indiana Tech.
That was close.
I got a bordering state. Does that count? I forgot that, Jim, and I apologize. Jim's been with the Ohio Ready Mix Concrete Association ever since his retirement from ODOT. And when he was with ODOT, his last position was a structures maintenance engineer. Did I get that right? See, I can remember something. Bad live. And they're going to give you the concrete solution.
Thanks, Joe. You know, when we came in this morning, I took a look at the audience, and one of the other gentlemen back there and I were conversing, and of course we knew Joe Neidhart for years. You know, he'd been around for a long time, and George Villacrest, we knew him for years, and George is a good guy. He works for the wrong people, the Asphalt Institute, but that's okay, all right? But we both just noticed that those guys have been around so long, they probably got socks that are older than me or him, okay? Concrete pavement rehabilitation. Rehabilitating concrete involves restoration, resurfacing, and reconstruction. There's 3 stages involved to this. The short line is called CPR 3. You want it to improve the structural or the functional condition of the pavement. Structural would be something that, of course, could handle the loads. Functional would be something skid resistance, noise, smoothness, something that is more user defined. Structural condition, of course, ability to handle the traffic. Functional is ability to accommodate the user comfortably. Pavement condition, over years, you usually have a terminal condition assigned to this, some sort of a present serviceability index measure or something like that, and that terminal condition is defined by the owner. The original pavement usually follows something in this type of a pattern. It functions up here in the early ages of life at a high condition, and then drops off in a manner something like that. Down here at this point right here, that's where you would have a minimum acceptable rating for your pavement condition. Of course, you want to start and make sure that it doesn't get down below this. You have that minimum established, or in your mind, whatever you do, like Pilates says, just have some sort of a plan, and you've got an idea of what that minimum is going to be. Well, you got to start making the plans and preparations up in this time before it gets down to that condition, especially if you have a lead time associated with developing the plans. This is what you should expect. Increase in the rehabilitation, and then come back in this area. That'll give you extended life by applying these procedures. 3 categories. Restoration. Basically the types of things that we're really going to concentrate on today. Of course, resurfacing is available to you, and then the reconstruction when the pavement gets to a point where it just cannot be either restored or resurfaced, and you have to do something serious with the pavement. And which you use, of course, in there, it depends on what the existing condition of the pavement is. Restoration is used up in these early ages, right up in here. This is where you're really in your preventive maintenance, your pavement preservation type of mode that you're in. You get down to this area down into here, you're going to be looking at possibly some resurfacing options. For concrete pavement, that might involve bonded overlay or an unbonded concrete overlay. It might involve, in lieu of a typical scenario would be go out there and just put an asphalt overlay on it. You might want to consider a diamond grind, structural repair underneath to the joints, the stress pavement, and then do a diamond grind on top of that. Reconstruction, of course, is when you have high levels of distress and you know that an overlay is not going to be effective. The timing of the rehabilitation is critical. Like I said, in this area right up in here, when you're starting to see some decline, you want to keep the pavement in a good condition so that it doesn't go under abnormal distress and shows signs of deterioration. This area right up in here, you might be looking at types of methods such as a diamond grind, a dowel bar retrofit. If you're starting to see some falling in your joints, maybe some slab movement because you've lost some support underneath with a subgrade, pumping, whatever. Some slab stabilization methods, pumping grout in there. This area again, like I said, after these methods, right at that point, you really need to restore just the structural plus the functional ability of the pavement to accommodate the loads and the users and what they expect out there. You might take a look at a bonded concrete overlay up in this area. If you have a decent structurally sound pavement that you can go in through and repair, do some spot repairs on. Down in this area right in here, you might be looking towards a unbonded concrete overlay, something a little bit more beefy to accommodate future traffic, and that should bring that back up to a good functional structural condition. Of course, if you're like so many pavement or owners of concrete pavements around the state and around the nation too, if you wait until the last few years of that life, then you're really going to be looking at something more major. You're going to be looking at a reconstruction, possibly tearing it out, rebuilding the pavement, putting in a new concrete pavement. So you either pay up here or you end up paying a lot more down here. When you choose your correct strategy, you have to take a look at several different things. The cause of your distress, whether it be a structural, voids underneath the pavement, loss of joint or loss of load transfer across joints, functional, skid resistance problems, faulting of the joints, something to make it functionally not acceptable. If there's material problems with that, the wrong type of aggregates were used. Back in the old days, we had a lot of decracking susceptible aggregates that were used in our concrete pavements. Since then, we've developed tests to monitor that those aggregates are less susceptible to decrack and for frost and freezing damage. Drainage problems, if you have drainage underneath your pavement, this is common problem. I know you guys in the townships and the counties, you're all familiar with what good drainage will do for a road and what improper drainage will do to a road. You might want to look at different alternatives in evaluation what your ride quality might be from each one of those alternatives, what your traffic and maintenance traffic requirements would be for the different alternatives, what type of conditions in the lanes you're going to have. If you're doing different things to different lanes, you might want to consider the lane that you're doing something to versus the lane you're not doing something to. They may be staggered. You may have them staggered in your rehabilitation strategy. What type of future performance you're going to get out of there, and of course, the cost. One thing you do want to consider, utilizing some of the more up-to-date and newer fast-track methods for concrete pavement that are available. Full depth repair, partial depth repair. We have some good additives for concrete that can be added in and for allowing for a quicker set time, higher strength gains in the early stages. Not just your typical MS and FS or mixes that ODOT specifies, which may set up, not give you enough time for actually finishing the pavement, but other additives that are available. And I think Jim Barnhart with High Ready Mix will get into some of those proprietary products. Another thing to consider under fast track would be possible use of a maturity meter. Maturity meter is based off the heat of hydration gain in the concrete pavement, and that's correlated to a strength gain. So you wouldn't necessarily have to wait for your beams to be busted or your cylinders to be broke. You use the heat of hydration method in the maturity process to go ahead and tell you what your anticipated strength gain is at a certain point out there in time, actual field measured probes in the pavement themselves. It's a relatively inexpensive method, and I think if some of you go to the Ohio Transportation Engineering Conference in October, there'll be a full session that'll be devoted to maturity meter testing and the whole process behind that. The maturity meter was used up in an unbonded concrete overlay application up in Cleveland in the downtown square there, where they had a concrete base and they wanted to go ahead and beef up those bus pads areas where the bus stops were. They put a bonded concrete over in there. They used a maturity meter to analyze and what their strength was at the time of setting and paving, so they could open that up as soon as possible without waiting for results to come back from testing labs and such. So there are some good methods that are available and some products that are available to help you get a high strength gain for concrete pavements in very short periods of time, within 12-hour periods or less. Of course, for concrete pavement, there's several different distress types. More of the structural problems would be the cracking, where you don't want to have the cracks happen. Concrete does crack. Eric said what he said was true. The longest that the slab's going to be is the day that it's been poured, right after it's been poured and in place. And from that point on, as the heat of hydration goes on and it loses some of its moisture, it's going to shrink. Nowadays, instead of using longer joint spacing, which would allow those joints to open up more, we use shorter joint spacings. We use 60 foot typical in some of the original interstate. Now we're down to 15-foot intervals on our transverse joint spacing. What that does, that allows the concrete to go ahead and break at those planned joints at the 15-foot joint spacing instead of the 60-foot spacing, because you're going to get those cracks anyways. We just didn't know it at the time. Or if we did, we anticipated that the structural steel mesh would hold the cracks so tight together and would last forever that then we wouldn't have problems. But that's not the case. Steel under attack by water and salt will not last forever. That's why we're making a big push towards plain concrete pavements. Shorter joint spacing, 15-foot joint spacings without those steel mesh. All it is reinforced with heavy steel dowel bars at those plain joints. Other type of things, when you have mid-panel cracks and or a cracking, or the joint itself, and you might have some aggregate interlock problems. Now, if they aren't reinforced, if it's a mid-panel crack and all you have is a steel trying to hold it together, it's maintained by aggregate interlock. But as the loads go over that, you start getting that movement. It just starts out real small over time, but as you bring it, as it goes, through its life and its repeated cycles under heavy truck loading, you can get a lot of movement in that slab, and that's where you're really starting to lose your aggregate interlock. That's a problem. That'll cause deterioration at that joint or that crack. Durability to stress, again, primarily from your decracked aggregates. Punch outs, there's not a whole lot of continuous reinforced concrete pavement being used now. ODOT doesn't use it at all. Punch outs were a problem with that, primarily due to, I think, a lack or deterioration of cross section of the steel, or deterioration of that. Functional type of stresses, we'll talk. Faulting, where you have one side of the crack or one side of the slab is higher than the other, causing a fault, noise problem if you do have that, possible surface polishing or incidental surface defects. Transverse cracking. Crack is going to occur where it wants to. Like I said, with the plain concrete pavements that we spec out today, you try to put them at 15 foot. What you want to do is you want to encourage that crack to develop at that joint. These transverse cracks that happen mid-slab can be a problem. This is the reason why we go to shorter joint spacing. Because with a 15-foot spacing on the transverse joints, we've been able to eliminate basically most of our mid-panel cracks. Transverse cracks could be also caused by problems with overloading. Again, the long joint spacing that I talked about. Typically, they used anywhere from 40 to 60 foot back in the old interstate areas. Now we're looking at, for plain pavements, we're looking down 15. If the joint itself is sawed too late or is sawed too shallow for a transverse construction or transverse joint, it needs to be, the sawed cut has to be at least T/4, at least a fourth of the depth of the concrete slab. You get in there too late with the sawing, there's only a window of opportunity after that concrete sets up, and when it's time to saw it, which before all those other cracks appear. And if you wait too late, you're getting other intermediate cracks already developing. Curling and warping, if you have temperature gradients or moisture gradients in the early stages of concrete pavement from the top, between the top and the bottom of the slab, could cause the slab to curl, warp. Again, with the shorter joint spacings nowadays, we're seeing it's a function of the slab length, and you're getting less of the problems associated with the curling and warping because of that. Loss of support. Back in the old days, they used a 310 aggregate base. ODOT spec had a higher percentage of fines than the 304 that we use nowadays. Fines were a problem because of the moisture getting in there underneath the pavements. Drainage wasn't that big of a deal back in the late 50s to early 60s. And over time, we'd get some pumping of the fine material out of there, and it'd create voids underneath the pavement. Well, that happens at a joint where you have trucks going over. If you don't have good load transfer from one slab to the other, you're going to get differential settlement, differential deflections in that slab. And that'll cause pumping. It'll pump those fines out of there when the moisture is available to it underneath the pavement. That's been a problem. Now with the elimination of the 310, better drainage, we haven't seen as much of that problem at all. Settlement and heave is always a problem if you've got those types of subgrades that are susceptible to settlement if it's not been compacted properly, not the proper material, heaving. All those things add up to ununiform support for the slab underneath. Those can be a problem, can cause cracking such as this. Base restraint, where you're actually, when the concrete shrinks, if it's held back by the base. If it's a long slab, you're going to see some cracks. Typically our 60-foot slabs cracked every 20 feet. Part of that was the reason why it just wasn't able to, it was being restrained by the base from cracking enough so there was more stress in the middle of the slab. Corner cracking, a lot of times you'll see that. That's a typical distress that you'll see out in the field sometimes. Again, primarily due to loss of support because of the pumping of the fines, like I talked about before. It can be a function of a long joint spacing, which we've shortened up. Curling and warping now. Again, with a shorter joint spacing, curling and warping stresses are not as critical. Again, it can also be the settlement or heave from the subgrade below that. Longitudinal cracking. Lots of times if this is located near a center line joint, it's due because it wasn't deep enough, sawed deep enough originally, or it was too late when it was in there and sawed. The crack already developed somewhere out beyond the centerline, the planned centerline joint. Again, it can be if you have long joint spacing, that can also influence it. If it's near the edge, typically you'll have some sort of a loss of support or a loading condition. Or again, it could be ununiform support underneath there, either a loss of support or a settlement or heaving of the subgrade. This severe of a crack right in through here where it just propagates out, that's typically where they have a lot of intersecting cracks. You have a lot of different stresses from different ways. It's typically because of loss of support. That could also be, again, like I said, some of the other pictures up here, it'll show you some of the examples of loss of support and what to look for. Deterioration in the cracks. After the crack, if the crack develops or at the joint sometimes, it could be because of the incompressibles that have dropped down into that joint, allowing for full movement, compression of that crack itself, holding that back, creating point-bearing loads within the crack itself, creating high stresses closer to the surface of the crack, and could possibly pop up and cause some spalling. Material durability problems could be also associated with this. If you have decrack type of susceptible aggregates used in the concrete, which again, like I said, we have tests now for that to help eliminate that. If you follow ODOT specifications. Some of the old inserts that we used to use can cause problems, something similar to that. Of course, an extreme case would be if it was it would actually blow up, but that's rarely seen. Other distress types, again, like I said, the decracking of the aggregates. Look in the pattern, something sort of like that. Again, because of poor quality aggregates that were used, we have the testing now available to test to make sure that we use higher quality aggregates that are not absorptive of water. The water being in the pavement to begin with. At a joint, of course, that's probably states your case for keeping those joints sealed. And then you have to have a freezing temperature on top of that. Another distress that you might see, typically you don't see this in Ohio because we don't have the reactive aggregates, but an alkali silica reaction. This is a chemical action between the alkalis in the cement and the concrete with certain silica, high silica aggregates. But again, like I said, it's typically not seen in Ohio. Punch outs in a continuous reinforced concrete pavement could be due to low steel content, high edge deflections due to loading, the crack spacing pattern that's developed across associated with continuous reinforced, and also a loss of support underneath the pavement. Faulting, just the difference from one slab to the other. As you go across, the faulting actually develops because of the loads going over to the high truck loading primarily. It drops down or it approaches a slab and it deflects the slab and starts pumping the fines out of the material down below, whatever's supporting it. And if you don't have some sort of a load transfer device, heavy dowel bars, something like that across that, the only thing that's holding it together is the aggregate interlock. And if the joint opens up, you get more space in there, you even get less aggregate interlock. So load transfer, poor load transfer would be the reason for that. Loss of support, pumping of the fines like I talked about, would also be a cause of that. Now the alternatives we're talking about here, the restoration methods that I'll get into, are all to help and improve the pavement. Different alternatives will give you different levels of improvement. There may be outside factors, of course, political, something like that, that you may have to take into consideration. Restoration usually applied at this level down here, at this time right down here, would not help you very much. Restoration methods that I'm going to talk about actually preventing the big problems that will happen down the road. Try to keep your concrete pavements out there for the long term. Should be applied in this area. Resurfacing will only give you a little bit more. Again, if applied down in this area right here, it probably ought to be applied. If you're going to have to resurface, you need to do it up in this area before the higher in the curve. Reconstruction would be at this point. That would probably be at this option right here where you are in the curve. That would be your best option at that point. There's a trade-off with the rehabilitation. If you do the heavy stuff early on, you're going to get high annual costs. It's going to cost a lot of money. You're going to get good performance. You're going to pay out your nose for it. If you just try and do, if you just try to do only the restoration type of methods that I'm talking about, but are applying that way down here in the life of the pavement, you're not going to get the good payoff. That really should be the annual cost will actually be lower because you haven't done anything substantial to it, but you're not going to get the performance that you want. Restoration up in this area right in here will cost you less and will give you the biggest bang for your buck. As you go down the road, or down the ladder here, you've got resurfacing costs that will start entering, plus a combination of restoration. Cost you a little bit more, but it'll give you the biggest bang for your buck. This area right in here is where you really need to be placing your time and efforts and your money. Get down to the low end there where you have low performance, you're at the end of the life of the concrete pavement, you're going to have to pay some more because you're in the reconstruction mode. Some of the restoration methods that we're going to talk about will help to extend that life longer so you can delay something like that from happening. These restoration techniques that I'm talking about are actually not that intrusive when you take a look at actually what you're actually gaining from that. Full depth repair does call for a cutout and actual full replacement of a section of the concrete pavement or multiple sections that are deteriorated. So you have to take that into consideration as far as how you're going to handle maintenance of traffic, things like that. With some of the fast track methods that we have available, and I think Jim will probably get into this in a little bit more detail, some of the fast track methods available, we can minimize the disruption to traffic now better than we ever have before. Partial depth repair, taking out a section of the top portion of the concrete pavement that might be deteriorated, causing you some problems, and replacing it with actually a bonded inlay. Diamond grinding, we're actually taking off the top surface layer of the concrete pavement with the diamond saw blade drum. John Reese is our next speaker after Jim. He'll get into that considerably. Joint and crack resealing, another method that you can go ahead by keeping incompressibles out of the joints and also keeping moisture out of the joints. Slab stabilization, the actual pump like a pozzolan grout or some material such as that to fill up the voids underneath the pavement that might be occurring to give uniform support to the concrete pavement. Retrofitting dowel bars. There's a project going on right now on I-75 in Findlay County, or in Findlay, in Hancock County, that has a combination of full depth repair, retrofitting of dowel bars across cracks that have developed in some of the slab panels. It was a longer slab back in 12, 13 years ago when it was constructed. I think 21 to 27 foot joint spacing. I think it's 27 foot joint spacing. Reinforcing mesh was placed in there, so when it did develop a crack, hopefully that reinforcing mesh would hold it together. Well, the reinforcing mesh was a little bit light, and it's gone ahead and gone under attack from the environment, and it's starting to show there's some movement at those cracks. What they're doing, they're taking dowel bars and they're actually putting them in place, cutting slots in the pavement and placing dowel bars in there so you do get that load transfer across that crack. And I'll go into some detail here a little bit later. I've got some slides on that. Retrofitting concrete shoulders. I think ODOT has had some questionable success with that. I think a lot of it is due to the selection of the concrete pavements. Where the pavements that they chose were old to begin with. To go in there and retrofit that with new concrete tied to the existing concrete, you probably didn't really get a good payoff for them. The other thing you might want to always, this might work in a concrete pavement that you realize that after the fact, maybe we should have had shoulders on there. While it's still in a relatively young life, 5, 8 years, it's in reasonably good condition. You can go ahead and put down and widen those shoulders out there with concrete, tie them together into the existing pavement, keep the joints in the same location as the pavement was, and that'll help also spread the load as trucks go over onto those corners on those edges of that concrete pavement. Another technique is for longitudinal cracks is cross-stitching. So we actually put cross-stitching tie bars drilled into the pavement and epoxied into the pavement at angles like that to give you a cross-stitching effect. Full depth repairs. Basically any type of repair that is greater than requires greater than 1/3 of the slab depth removed. You're removing, you're replacing all the entire depth of the concrete. You come back and then you're going ahead and put in drill in dowel bars, placing them into both of the pavement edges that you're tying into to give you a good load transfer device at that joint. You'd use full depth repairs where you would see something like that, where you'd have deterioration both the top and below the slab. Something like that, you'd just cut it out, find sound concrete on both ends, cut that out, do a full depth repair, and that should help, that would definitely help alleviate problems for future pavement. Something like that, you come out here to this edge, you come out here somewhere like that, and come in and do a full depth repair to help put in new concrete pavement in that location. Some pictures of what it would be. There's the cut. The dowels being epoxied in. The dowels, they have a certain amount of flexibility out there in the location of these dowels in the slabs. These dowels are really, they're drilled in. An experienced CPR contractor would use a slab reference multi-gang drill bit device that would drill all these holes simultaneously, slab referenced off the true perpendicular cut of the pavement, plus also the elevation of the slab. That's in order to align the dowels properly. The holes are drilled properly to begin with. The dowel alignment will be proper after that point. And it's real important that these dowels be located true parallel to the center line and true parallel to the surface of the concrete. You do have flexibility. In this location right here, there's an existing crack. That's not where you want to have a dowel bar. That should have been moved over. They should have spaced these things differently at that point. And you go in there and you fill it up with concrete and finish it off. This type of operation, if you have multiple patches and things like that on a concrete pavement, you'd come back then after it was all done and you'd do a full diamond grind across all the lanes, and it'd give you a nice smooth riding pavement after it's done. Partial depth repairs are where you have deterioration just in the upper third of the slab, spalls at joints, corner spalling, things like that. You go out there and you try and find these things. You have to use some device. You use a hammer, maybe, in some cases, or a chain, some sort of a sounding device. to actually find out where your solid concrete is outside of that spall area. When I was with the county engineer's office in Marion, we used to go out and inspect bridges. We'd climb underneath the bridge and we'd hammer all the concrete. You could tell the solid stuff was the one that gave you a ping, just about bounced back into your face after you hammered it. The other stuff was what we called punky. And that was where you wanted to get it. It sounded like it was filled with wood sometimes. Identify those areas for the patch. Come in with a lightweight hammer and cut that out after you've gone ahead and saw cut the perimeters to give you a nice, clean, smooth face to bond to. Jackhammer that out. This is the joint location right in this area. They've just gone back far enough and gotten down to firm concrete. Same thing here, only this is at a joint, and what they're doing, they're placing in joint filler to reestablish that joint there. You can't let this patch go right up to the next slab adjacent to it, because once that slab starts moving, if it's trying to expand in a hot weather or something like that, that patch pop right out. So you want to reestablish that joint, just like the existing concrete is. This is probably the only place where we reckon we could okay carbide milling, is when you're trying to cut through for a partial depth repair. This would be a half moon if you used a carbide milling drum type of operation. This you would go ahead and saw cut with diamond saw blades, a nice perpendicular vertical edge, and then you come through here possibly and carbide mill that out. The reason why we don't like seeing a whole lot of carbide milling on concrete pavements is because it's more of an impact type of process that actually beats on the adjacent concrete and can actually cause microfracturing of the existing concrete. You definitely don't want to use carbide milling for diamond grind in lieu of diamond grind for the concrete surface. It's a picture of one of those half-moon constructions of carbide milling. They did 1984 on existing concrete pavement, and there it is in 1998. It's in pretty good shape. You can almost tell that that's been ground, also diamond ground across that pavement surface. Diamond grinding process, typical machine like that, heavy machine, bears down onto the concrete pavement, pressure is applied onto this cutting head, which is a drum of diamond saw blades placed in close proximity to each other, probably about a 3, possibly a 4 foot length of drum, and with multiple cutting heads in through there. John Reese will be talking later on. He'll get more in specific about the diamond grinding. I'm just going to cover some of the generalities. It improves the rise by, you can remove the faults that might be existing at the joints. If you do have slab warping, it can remove that because you're actually reestablishing a new true profile. Other surface deformations, like the old studded tires we used to have in Ohio, but we don't have anymore, where it caused problems, you can eliminate deformations like that. It gives you a good smooth surface, but it also gives you a ground surface, a groove surface, which allows cuts down on your hydroplaning. They can reestablish and raise those skid numbers up to good levels. It can also be used to correct cross slope problems that you might have. Here's what it looks like, the diamond ground surface versus the existing. Probably anywhere from 1/8 of an inch to maybe 1/4 of an inch high end, typically taken off. Gives you a corduroy appearance, longitudinal grooves at that point, good friction characteristics, good pattern for allowing drainage away from the tires to help eliminate any hydroplaning problems. There's a close-up of a diamond grinding head. Each one of those is a diamond saw blade. What, John, there's probably, what, 60 of those across there or so?
It varies.
How much? About $100,000. Those are industrial diamonds that are used. Joint and crack resealing is probably the simplest thing you guys could do for your concrete pavements. Minimize your water intrusion down into through that crack and down into the subgrade below the pavement. Always good to keep water out of subgrades. Everybody knows that. Minimize getting any incompressibles in there. But as we move towards plain concrete pavement nowadays with shorter joint spacing, what you're actually doing, you're taking that coefficient of expansion of your concrete materials and your aggregates, and you're actually distributing it over, the contraction and the expansion. You're actually distributing it over many more joints. So you're getting, actually, theoretically, you get less movement at each one of those joints than what you would for the pavements who had longer joint spacing. One way of cutting in and removing the existing material in the joint would be to use a diamond saw blade. Cut that old filler material out, reestablish the sides of the joint, give you a nice vertical surface to adhere to. Of course, it's important, again, to get in there and clean it out. This is a typical hot mix application to reestablish your sealant. One of the methods. The other methods would be silicone, possibly, but I think hot pour is probably one of the preferred methods. Load transfer restoration, this is what I talked about. If you have a slab, two slabs, and you have a joint between them, as the heavy truck loading comes across, eventually if you don't get that aggregate interlock or something like that to hold, you don't get transfer across that joint. This is actually zero transfer at this point, because where you have deflection at this point right here due to that loading, in the next slab adjacent to it, there's no deflection. So that's zero load transfer. This is good load transfer because you have the deflection in your preceding slab and your following slab deflection are the same, because in this case it happens to be a dowel placed in there across the joint. You have good load transfer. That's typically 100% load transfer. Dowel bar retrofit would be typically done with a gang assembly machine such as this, which cuts slots in the concrete pavement for placement of dowel bars to be retrofitted into the concrete pavement. These slots end up looking something like that. Typically we have 3 per wheel path. Take a lightweight hammer. You don't want to go down too deep. You don't want to be hammering that thing with a jackhammer on the back of a backhoe or something like that. You want to use something in a 15, maybe 30-pound range. Small hammer to knock those fins out of there. Clean that up. Place the dowel bars back in there. They have chair assemblies that they mount these dowel bars on, and then a strip to reform that joint. So again, like I said, you don't get point-bearing load across there. You want to establish that joint exactly the way it was. The material you'll be putting in there will be a type of material that allows for this quick setup time, high strength, similar low shrinkage type of characteristics. And that'll establish your load transfer across that joint. Slab stabilization, again, like I said, if you have a joint here or a crack and it's starting to move on you, starting to pump some of those fines that I told you about down there, you may have a void underneath there. Have to get out there, and you can drill holes in there and fill that up, backfill that up with a low pressure grouting mixture, some sort of a pozzolan mixture or something similar to that has high flowability, is able to get into the recesses and the voids underneath the concrete pavement. That reestablishes that uniform support that you need underneath there, and then thereby reduces the stresses and deflections in the concrete pavement at that location. It's real important. You want to fill the void, but you don't want to raise the slab. It's not slab jacking. Slab jacking, you would bring it up and it would give you ununiform support, and then you'd have problems on top of that. So all you're doing, you're trying to just fill the voids with a method such as this. Longitudinal crack repair, retrofit of concrete shoulders, just briefly. The cross stitching that I talked about is something you would see in a longitudinal crack that would be a repair method. You add reinforcement to these cracks, and you're either inserting, I guess you can insert tie bars horizontally placed, but you can also do your cross stitching method, which actually drills it in at an angle and cross stitches across that crack. That's only used in a longitudinal crack and not in your transverse. Retrofit of the concrete shoulders, again, it does add concrete shoulders to an existing pavement. If it's tied, it allows for distribution of that load, particularly those trucks as they go down the side of the edge of the pavement. If you've got them tied now with a concrete shoulder, it distributes that load over onto the shoulder material also. Gives better lateral support to handle those loads. Some limited success in Ohio, I think primarily because of the types of candidate projects that they used it on, but it has shown that it does work in particular pavements that are in decent shape. Certain windows of opportunity are available for using the different techniques that we're talking about. It has to be feasible. It has to be able to correct your distress. It has to be applied at an appropriate time when it will be effective. Sometime on that distress curve that I showed you. You can use trigger or limit values such as that. And I've got an example of a couple right here. For a high traffic volume type of road, you might, let's say, use deteriorated joints, a percentage of the joints. Anywhere from 1.5 to maybe 15%. And then for a low volume road, you could use a little bit higher trigger values. Load transfer, measuring that, less than 50%. Whatever way you'd want to set that up in a program such as that. That's for your structural values. For your functional, more of your functional values, it'd be ride, more ride associated. How smooth is the pavement? Does it have faulting? If it does, you want to go ahead and for a high traffic, and again for high traffic volumes, you'd be using lower limits. For lower volumes, you could accommodate, go ahead and setting those limit and trigger values up a little bit higher because of the low traffic. Restoration performance, and your diamond grinding in particular, has shown to be provide several different generations of diamond grinding on concrete pavements have shown to have provide life of 10 years or more. Some of the pavements around the nation have been ground 3 times successfully and are functioning very well. You need to do your preliminary engineering early if you're going to go ahead and do that, because as you want to get ahead of the curve, ahead before the distress has reached those critical values. And of course, the overall effectiveness of your restoration method depends on your construction quality, other restoration activities you may have, the condition of the pavement, and such. Comparison of some rehab restoration techniques that were used in North Carolina and Washington. On North Carolina I-26, we used concrete pavement restoration, which in this example consisted of dowel bar retrofit followed by diamond grinding. It was on a project size, a little bit different than what the crack and seat and the AC overlay was, but it showed that it was significantly less than the other method there. In Washington on I-90, a dowel bar retrofit used as a rehabilitation technique cost significantly less than the AC overlay that they had put down. We've conducted a study here in Ohio, studying several different adjacent sections of concrete pavement adjacent to asphalt pavements on interstate. Now, all the interstates were built back in the late 50s, early 60s, so they were almost entirely 9 inches of concrete pavement on top of 6 inches of 310 base, or something similar to that. Ohio, over the past 30 years or so has used different methods. Primarily they used, in order to establish the ride back on that concrete pavement, just overlaid it with asphalt. We took a look at those sections that have concrete pavement that they didn't overlay with asphalt. They went in there and they actually maintained the concrete surface by full depth repair, partial depth repair, diamond grinding, and we concurred through our studies that it was 30% less expensive. They spent 30% less maintenance funds and overall construction funds on those concrete pavements than they did on those asphalt pavements over the life of the pavement, or over those asphalt overlays. So it pays to keep concrete. These methods that are used have been proven across the nation to actually be beneficial in terms of cost and pavement longevity. Other resurfacing activities you might associate with concrete pavements would be a bonded concrete overlay. In the earlier life of a concrete pavement, if the pavement's in decent shape, and you can go ahead and bond to it with a bonded concrete overlay, or an unbonded concrete overlay, which would be putting an asphalt layer down or something like that, some thin asphalt layer and then another layer of concrete on top of that, typically 6 to 8 inches, in order to reestablish good pavement structure. Concrete pavement overlays on asphalt pavements that have shown some promise would be that conventional white topping, typically in the range around 6 inches over asphalt pavements, that may be causing some problems. Some ultra-thin applications too, usually in the high stress areas where you have a lot of truck traffic, rutting, some shoving. In summary, your concrete pavement restoration repairs into structural and functional deficiencies in your pavement. It can improve your pavement condition to an acceptable level, and the appropriate activity depends on your existing pavement condition. As your condition declines, the optimum activity changes. So you have to base your decision on what strategy to use depending on where it is in that curve that I talked about. And you need to apply that activity at the proper time. You guys have any questions? I'm so fortunate to get you guys after lunch. Nobody has any questions for me.
When you get decracking,
yeah.
is there any other method, like an epoxy sealant or anything else you could do at a lower cost, and then you go in and saw cut that out or grind that out? You know?
If you have your deterioration such as a joint, something like that, if it's decracking, you've got a problem with the aggregate itself. Okay. The reason why I think we've experienced problems at the joints is because that's where the moisture collects. Okay. Now I'm going to let you guys into a little secret here. I've told you to keep your joints sealed. Well, there's some studies out there that say don't seal your joints. There's been studies up in Wisconsin that have said they see no difference between sealed joints in concrete pavement versus the unsealed joints. And they've done 30, 40 years of study on that. But they're about the only state who believes themselves. Okay, nobody else believes them. All right? There has been some study down at Ohio University done by one of the professors down there that has shown that maybe your moisture is less at those joints if you don't seal them. Maybe it allows the moisture to escape through the joint, or I don't know. I don't know what it is, but we're starting to see some indications that it might not be it might not be that serious of a problem as we thought. Particularly with your shorter joint spacing, your incompressibles, like I said, you're not getting the expansion contraction distances in those joints now because you're spreading it over more joints. But to answer your question, I really think probably cutting that out if you've got decracked aggregates and you're already experiencing those problems at that joint location, probably full depth repair at that point. Maybe Jim, Jim's got some slides on full depth repair, and he can address. Maybe he can give you some input on that too. Any other questions, guys?
On a partial depth, what's your minimum plus thickness you recommend on a partial depth repair?
Typically no more than a third of the depth of the existing concrete. That's typically your cutoff. If you have to go lower than that, then you're probably getting too far down for partial depth. Anything else? Thanks, guys. Oh, wait a minute. One other thing, all right? We've got a table back here. We've got some stuff, some publications. There's the ones that have multi-piles on them where you have more than one. Don't take the only one to have, all right? But take the ones that I've got, like, 30 or 40 of these publications. This is also a good restoration, man. It's concrete pavement restoration. It has a lot of our latest information and publications on that in detail. Goes into everything that I talked about and more. So you might want to take a look at this before you leave tonight, or then John and Jim's got some information to give you. And then John, I know he wants to talk to you about diamond grinding and some dowel bar retrofit and things like that. All reference to these members. So go ahead and take a look at this material that we have back there when you get a chance.
Okay, I've got, looks like 15 minutes to tell you everything I need to know about, or everything you need to know about concrete, right? Which is about all I know, so I think we'll be in good shape. How many of you actually do concrete repairs yourselves with your own crews or whatever? Okay, or attempt to do repairs at least? Okay, well, I'm going to talk about some of the possible ways of getting the work done faster. Okay, everybody's in a hurry these days. I constantly hear that, well, the reason we don't like to use concrete pavement is because it takes too long to build it. Everybody's concerned about today, not 30 years from now, right? And traditionally, that's the reason I know asphalt does at least promote itself as being able to drive on it faster. And there's no question about that. But there are some things that's happening in the concrete world that allows you to do some amazing things with concrete. I'm not going to spend a lot of time on any of this because Don has already covered full depth patching, partial depth patching. The only thing I can say about that is that surface prep is important. Saw cutting around the perimeter is critical, which is labor intensive, no question about it. But if you don't get all the unsound material out of the hole, and this goes, the asphalt guys have already talked about this as well. Same thing applies. If you don't, if you don't saw cut, if you don't remove all the unsound material, you're wasting your time out there. And I hate to see people wasting their time. So you got to do it right the first time. I just wanted to let you know that in the ODOT spec book, there's some fast setting materials you may or may not be aware of that's pretty commonly accepted today. Most ready mix producers are aware of these mixes. And primarily it's the FS mix and the MS mix. Nothing fancy, nothing tricky about those letters. FS stands for fast setting and MS stands for moderate setting. But the FS is, I figure out where my pointer is. Well, I don't see it. Anyhow, the FS mix is a 900 pounds of cement. Oh, okay. Thank you. You bet. No problem. The FS is a super fast setting Portland cement concrete. You can get it out of a ready mix truck, in other words. It's got 900 pounds of cement per cubic yard. That's pretty hot mix of concrete. But you'll notice it says it may be reopened to traffic after 4 hours. Now, that's all things considered. You know, that's at 60 or 70 degree weather. You get down to 40 degrees, obviously it's not going to happen as fast. You notice it says provided, you can open it to traffic after 4 hours, providing test beams have attained a modulus of rupture at 400 psi. In other words, you break a beam, you got to get at least 400 psi before you can open it to traffic. But that is a fast-setting mix, and it works pretty well in hot or in cold weather too. That's the advantage, one of the big advantages of this particular mix. Calcium chloride may be added or shall be added, it says. Obviously, if you've got steel, I'm an old bridge guy, so I don't like to be using calcium chloride in concrete. There are other accelerators that you can get that are non-chloride accelerators. You know, here we are trying to prevent chloride intrusion into concrete. Now here we are putting chloride into concrete. You know, think about that. That doesn't make a lot of sense. But ask your ready-mix producer to give you a non-chloride accelerator. There's lots of those things available these days. I don't agree with using chloride. But anyhow, it does say here any other approved accelerator may be used as recommended by the manufacturer. Okay. The other key here is with this particular method is immediately after the curing compound has been applied, and I'm going to talk a little bit about curing compounds in concrete work. That's the biggest fallacy I see out there by contractors and by folks doing it themselves. They don't understand the importance of curing. Once you get the concrete placed, you got to keep the moisture in it. You don't want to let it dry out. And that means immediately after you get the finish put on it, you got to cover it up with something. That doesn't mean 4 hours from now. It doesn't mean tomorrow. And don't rely on sealers to do that job for you. I hear a lot of people run around saying, well, I'm going to seal my concrete. They don't get it. You know, if you seal it a week later, the damage is already done. Don't expect the sealers to make the concrete come back to life, because it won't happen. So you got to get it covered up immediately. And keep in mind, we're talking about pavements here. We're not talking about your patio or your driveway. So if you leave a little footprint in it, or if you mar it a little bit when you cover it up, who cares? Okay, get it covered. That's the key. Obviously, you don't want whatever you're covering it with to sink down into the concrete, but get it covered immediately. In this case, they say you should cover it with polyethylene sheeting first, and then further cover it with building board. Now that could be like polystyrene sheets, okay? And the building board should be wrapped in a black polyethylene sheeting. Why black? It absorbs the sunlight, builds more heat up in the concrete, makes it go faster, okay? And especially in the wintertime, you got to be using black to absorb the heat, okay? And place it tight against the surrounding concrete, weight it down to protect the concrete from the weather. So that's a 4-hour mix. It's fairly commonly used, and if you've got joints to replace, small slabs to replace, you might try that. Now, granted, you still got to go through all the rigmarole of jackhammering, saw cutting out the unsound material, jackhammering it out, inserting or putting your dowels in properly. That's all very labor intensive, no question about it. Still has to be done though. But the fact that it takes too long for concrete to set up doesn't really hold water anymore, not in today's market. Okay. Now the MS mix is a moderate setting, Portland cement. Again, that's in the ODOT spec book. May be open to traffic after 24 hours. So also you got to consider your needs out there. Is it always important to get the road open within 4 hours? Can you sometimes wait and open it in 24 hours? Chances are by the time you jackhammer the old concrete out, you're going to be into the job for 4 or 5 hours already. just doing the prep work. So it's probably going to force you to keep it closed overnight, no matter what. Minimum cement content for the MS mix is 800 pounds of cement per cubic yard. And again, you got to have test beams. You got to make your test beams, and if you can get them up to 400 psi, that's usually acceptable for it to open to traffic. Coarse aggregate may be 57s or a combination of 67s or number 8s. And make sure you get some entrained air in the concrete. That comes when you order that. When you order that particular concrete, the producer automatically ought to be giving you some air, but you need to check it to make sure that the air, that the entrained air is correct. Just to make sure you get that durability that you need in this part of the country. There's some other, and by the way, that particular specification used to be 499, specification 499 in the ODOT spec book. It's now a supplemental spec. It's 899. They've added a few little things prior to the entire spec book is really being rewritten at this point. So there was a few things a couple of years ago that they wanted to change in some of the specs. I've brought, basically I just made an excerpt of those two mixes, the FS and the MS, and they're laying back there on the table. So if you're interested, you can pick one of those up before you leave. So I wanted to bring that to your attention. There's also some other proprietary products out there that really look promising as far as what you can do to make concrete go off faster and be able to get on it faster. This is something you may, how many of you have heard of this self-compacting concrete? It's a fairly new technology, although I understand that the precasters are using it quite a bit because it's got a lot of neat properties, one being that you don't have as many bug holes or air pockets with this product. You don't have to use vibration. It's basically a self-leveling material. But here's the mixed design. You notice the cement content is down to something more reasonable. Instead of those 800 and 900 pounds per cubic yard mixes we just looked at in the ODOT spec book, this mix is back down to 700. The only somewhat unusual is that they're blending 8s and 57s. That's the coarse aggregate. Give you a little bit more denser mix. And they are using a high-range water reducer, a superplasticizer otherwise known, increases your slump so that you can work with the concrete a lot easier, but you don't really add more water. So you don't lose strength because you're adding water. Okay? And that's important. You notice the initial slump, this would just be the water slump, just for mixing the material up, is only 3 inches. That's not very much for concrete, but when you dose it with the high-range water reducer and the VMA, which is this particular product is the Master Builder's product called Real Build, you get actually, then they have to start measuring it not in slump but in spread. When you pull the slump cone out, how far does it spread? You can't even measure the slump. So you're looking at a 20, well, just after the high-range water reducer is added, you get a 19-inch spread of the material that was in the slump cone. After you add the VMA, you get a 26-inch spread. So it's basically soup. But the advantage is of this particular product, it doesn't allow, it keeps the coarse aggregate from settling out, which is ultimately the problem a lot of times with a real soupy concrete. Anyhow, this was a mix that was used at Wright-Patterson Air Force Base back in March. It's actually still going on as part of the new control tower that they're building. So it's kind of interesting. This has been approved by the FAA, by the way. But look at these strengths. 4,700 psi in 24 hours. That's pretty impressive. With only 700 pounds of cement, You'll notice there's no microsilica or any of those other commonly used materials like are used in bridges these days. It's really more of a generic spec, except for the addition of that VMA material. 28-day strengths of 8,000. So pretty impressive strengths just in 24 hours. So that's kind of a neat technology that you're probably going to be hearing more about. Like I said, this particular product is a master builder's product. There are other suppliers. I think Grace, W.R. Grace has a product that does some similar things. So there's a lot of people in the industry who's kind of excited about this new chemistry, you might say. And it really doesn't. I did, like everyone, I asked about the cost. That's always, everybody always has this hang up about cost. The producer that furnished this told me that it cost about $30 a cubic yard more. At least that's what they charged the contractor. But they admitted that that was probably way more than what they really needed to get. They didn't tell me what the actual cost was, obviously. But to the contractor, this mix still only cost, well, less than $100 a cubic yard just for the material. So it's not a huge number for the advantages you get with it. Here's another material that we've used actually in pavements. This is a Sika product, which is another chemical admixture. It's called a hardening accelerator, and it allows you to, especially in colder weather, you still maintain fast-track construction, minimizing traffic disruption, which is everybody's concern these days. And again, notice the cement content is 750 pounds. Nothing real unusual there. They are using a water reducer or a super plasticizer in it. But here, if you can kind of see this graph, this is normal concrete here. And you can see after 8 hours, they're up about 1,000 psi with normal concrete. And with this rapid hardening admixture, they're up about 4,000 psi in 8 hours. Okay, so and typically within about 6 hours, we've found in pavement repairs you can get it open to traffic. Okay, you usually have enough strength. So another interesting product. This is a little bit different than what we're talking about, but I want to talk a little bit about equipment and techniques for placing concrete. Many of you already know this. This is a white topping job, by the way, part of which is a bonded overlay on top of concrete. Part of it's going to be a topping just applied to the top of the asphalt at an intersection. But that's not really what I want to talk about here is, what I really want to talk about is if you're out there placing concrete in these patches, and if you don't have some kind of a vibrating screed, you're kind of wasting your time. And you're causing your people to work a lot harder than they should be. This is a homemade vibrating screed that ODOT District 7 has had for 30 years. Gasoline-powered vibrating screed. Takes all the work out. You notice there's nobody down on their hands and knees with a screed board. Okay? So don't make life any tougher than it has to be for the workers. That's what I keep preaching. A little simple device like this attached to a couple of 2x6s does all the work for you, basically. And again, you're just talking about a pavement here. You're not talking about your patio. You don't really care what the texture looks like when you're done, do you? I mean, yeah, you want a relatively smooth ride when you're done, but who cares if it doesn't look real beautiful? You want it to stay in place. You don't want to have to come back and do it over again. So a vibrating screed is important. There's lots of them available commercially now. This is a homemade one. And like I say, they've been using it for 30 years. They were paving over a situation there that should have been cut out and replaced like Don was talking about. Here's some other commercially available screeds. This is a fairly typical truss type vibrating screed now. You can get those gasoline powered, you can get them air powered and electric. So they're available in 3 different choices. This is a more heavy duty roller, vibrating roller type screed. You probably wouldn't want to use something like that on small repairs in a local community. I want to talk about cold weather applications, which is where some of these special additives really prove themselves. Who says you can't pour concrete in the wintertime? In fact, in reality, some of the best concrete is poured in the wintertime. In the summertime, the concrete goes off too fast. And it'll get hard fast, but it doesn't gain strength. It doesn't continue to gain strength. If you keep it cool and hold that moisture in it, it'll gain strength for months or years after it's placed. It keeps getting stronger, and that's a fairly well-known fact. Now, granted, working in the wintertime is tougher. You got to have the right equipment. You got to have the right protection for the concrete. You don't want it to freeze, obviously. You don't want the sub-base to be frozen that you're placing it on. So you got to keep the sub-base from freezing if you're going to be pouring concrete. But this was a job that, and of course the other thing is, you get into these situations, you know, the asphalt plants close down, you know, after probably the end of November, first part of December, so you can't get hot mix anymore. So in some cases, you have no choice. This is State Route 315 in Columbus. There was a big rush to get that open last January. There was only a short section of pavement yet to be placed, and it was originally designed to be built out of asphalt. The ODOT District 6 called us for advice on what kind of concrete mix they could use to get that opened up. So it was like a 700-foot long stretch, I think it was, that had to be placed in less than ideal conditions. Now you notice on the day of the actual pour, most of the snow was gone at least, but this is basically an MS mix. I just called Anderson's Concrete this morning to make sure that I was correct on this. This was an MS mix. It was not even an FS mix. This was an MS mix. They used hot water in it. That's another fairly easy thing to do to make the concrete go off a little faster. But nothing special about it. And it was placed in about 25-degree weather, maybe 30-degree weather. I think I got down into the 20s at night. They had blankets here somewhere. That's the only thing that, again, I constantly complain about on the job is look at all this concrete that's been placed and it's still not covered yet. I mean, just basics, people, just basics. You got to remember the basics in placing concrete. Okay, but even with that, it's you know, you can see that here they are texturing it, so they obviously got to wait for the texture to be placed. But they got a pretty long area here that could have already been covered with something. So just a couple other shots of, in this case, it was just they just formed it conventionally, nothing fancy here. Use one of those vibrating screeds. This would be a 10-foot straight edge just to make sure you get a smooth ride when you're done. And you notice they do have the blankets laying over here in order, even though they haven't used them yet, they're laying there, okay? And in this case, they bought brand new blankets. Maybe they were afraid to get them dirty or something, I don't know, but you got to use them if you got them. Also, keeping the subgrade from freezing. If you know you're going to pour, you can't let that subgrade freeze. So you actually have to cover the subgrade with those same blankets days, you know, several days before the pour. Okay, it can be done. It's a pain in the butt, but you can do it. Now back to curing in more climate weather. You know, keeping the moisture in it. Wet burlap with a soaker hose or soaker hoses covered with plastic. This is a bridge deck repair. Now we had a big windstorm this day and some of this stuff got blown off. You can see that the barrels got blown over and everything, but I was impressed by the fact that they were actually trying to do it right. The windstorm came up and kind of took some of their curing off. But this is a hole in a bridge deck, and they had it covered with wet burlap, soaker hoses, and plastic. That's the way to do it right. But you got to get it on there right away, as soon as you can. Most people are going to resort to curing membranes. Again, that's probably second best to water curing. But what's the biggest fallacy with membranes? They don't put them on soon enough, number one. There's really no excuse for not putting membrane on soon enough, because it's a spray-on. But the number two thing is they don't put it on heavy enough. You should make sure they follow the manufacturer's recommendations on coverage rates. It should be put on in two different directions at right angles so that you get a double application of it. That way you eliminate getting thin spots and heavy spots. Actually, they're doing a fairly decent job on this particular pavement. But again, where's the paver at? It's way the heck down the road here already. They waited too long again. Then you wonder why the concrete cracks. Well, think about it. It's not rocket science here, folks. So I can't overstress the importance of curing. And it's not anything real hard to do. It's just that everybody tends to forget about it, I guess. They're so worried about getting the concrete placed and finished that they tend to forget about that last very important detail. So again, if you're doing this stuff yourself, make sure you don't overlook the important stuff. And then, of course, making these beams. You ought to be making beams if you're placing this concrete yourself or the contractor's placing either one. This is the typical ODOT in-the-field beam breaker. They make their beams are about 40 inches long, so you can actually get 2 breaks out of each beam. So you notice this first beam, they broke it, it came up to 330. Well, it's not good enough. So then you wait another half an hour or an hour, you break it again. Okay, this will tell you when you can open it to traffic. Again, it's not rocket science, nothing high-tech here. Just a three-point load until you pump that thing up until it breaks the beam. So they actually had an opportunity here to get 4 breaks since they made 2 beams. That way you don't have to be screwing out making cylinders and taking the cylinders and having them broken. This is a lot better, quicker way of telling you what kind of strengths you're getting with your concrete. And I think that's it. Like I say, if you're interested, pick up one of these supplemental specs for the MS or the FS mix. I've also laid back here some of our membership directories. This is loaded with ready mix producers around the state. It's got names and phone numbers of who to call at these various producers. And if you want any information on these proprietary products I talked about, I brought some bits of information with me. Or if you give me your card, I can have more information sent to you about those new high-tech products that are out there today. So that's all I have. Kind of a rush here. Since Don took up all my time, I had to rush through this. But that's all I had to say anyhow. So.
Any questions for Jim? Okay, let's take
Thanks a lot.
break.